I'm going to answer questions from sample paper number 5, RK Bali Navigation book. This book that I am referring to is the fourth revised edition RK Bali book. Even if you have any other book, any other revised edition book like edition number 5, edition number 6, edition number 7, no problem. All the questions of the sample papers are same, whether you take fourth revised edition book, fifth book, sixth or the seventh book. So no problem there. So we can continue practicing these questions for the benefit of our exam. So let's start with question number 11. The position of aircraft that it would reach if it were flown in conditions of no wind is known as what? So here they are talking about no wind conditions, that means calm wind conditions. Calm wind conditions, okay? Or stationary wind, no headwind, no tailwind, no crosswind. So the position of your aircraft, okay, whatever the position of your aircraft, when you start from A to B, that B position, that final destination position will be what kind of position? So the correct answer is option Charlie, air position. Option A, DR position is nothing but dead, deduced, reckoning position. Now, deduced reckoning position will happen when you are flying in windy conditions, like you are flying in a headwind, tailwind, crosswind, whatever that is. So, in such scenarios, when you are flying in windy conditions, okay, the ground position of your aircraft, the position of your aircraft in the air with respect to the ground is called dead reckoning position. Okay, so you may be flying in an air mass, but because of headwind, opposing headwinds or favorable tailwinds, crosswinds, the actual position that you will cover with respect to the ground will be different from the air position. So that is BR position or deduced reckoning position. These are the positions that we are always working up in the air when we go from point A to point B on our cross country flights, right? So we keep on deriving these positions depending on our task, course, heading, wind velocities, ground speed, and we keep getting new and new positions time to time. But if there are no wind conditions, the whatever position you are in the air, that will be your air position, and same position will be on the ground. Question number 12. The sensitivity of a magnetic compass can be affected by what? So very important question. Now the sensitivity of a magnetic compass is directly proportional to the horizontal component of the earth magnetic of the earth magnetic field. Okay, directly proportional to the horizontal component of the earth magnetic field, and it is inversely proportional to the vertical component of the earth magnetic field. Okay, horizontal component and vertical components. Now on the earth, remember, let's say consider this is your earth. Here is your equator, 0 degree equator. Here is your 90-degree north pole, 90 degrees south pole. So at equator, horizontal component of the earth magnetic field H, horizontal component is maximum, is maximum. At the poles, horizontal component H is minimum. But at the poles, contrary to this, the vertical component of the earth's magnetic field, vertical component of the earth magnetic field is maximum. At the equator, the vertical component of the Earth magnetic field is minimum. So that's why we say that magnetic compass is best operable in the equatorial regions or low latitude regions. But as you go away from that equatorial latitudes, away from this latitudes towards or near the polar regions, the magnetic compass becomes less and less reliable, because over there the horizontal component of the Earth magnetic field decreases in value, and vertical component of the Earth magnetic field increases in value. That becomes more and more dominant. As a result, the magnetic compass, which is directly proportional or dependent on the horizontal component of the Earth magnetic field, becomes less and less reliable as you go near the polar regions or to higher latitudes. Okay, so here the sensitivity can be affected. Sensitivity is nothing but the working mechanism. Okay, is can be affected by horizontal component of the Earth magnetic field, vertical component of the Earth magnetic field, both of the above. So correct answer is answer Charlie. Okay, it is affected by horizontal component as well as vertical component. Question 13. When cruising on a westerly heading on a direct reading compass, what will it indicate? So you are cruising on a westerly heading. So this is related to acceleration and deceleration errors of direct reading magnetic compass. Now here they have given us northern hemisphere to consider. So let's consider that part of the earth, the northern hemisphere. Okay, this is the north direction, this is the west direction, this is the east direction. You're flying on a westerly heading. You're flying on a westerly heading like this. Okay. Now when you accelerate on this westerly heading, whenever you accelerate on easterly heading or westerly heading, westerly heading, the direct reading magnetic compass will show a northerly direction, will show a northerly direction in the north, in the north hemisphere. Now in order to, so instead of showing 270 direction correctly, the magnetic compass will show any direction more than 270, like 300, 340, 350. Okay, depending on your acceleration magnitude, it will tend to point towards northerly direction, any direction that is to the north pole, near the north pole. Okay, and that to happen, what will happen in the magnetic compass? The magnetic compass will rotate anti-clockwise. Compass will rotate anti-clockwise. Okay, if you are flying on the westerly heading, the compass will rotate anti-clockwise like that. So the northerly directions, all directions near the North Pole come closer to this aircraft heading, and that will be shown to you as aircraft flying on that particular northerly heading. So the correct answer here is, when cruising on a westerly heading, pay attention to the word cruising, because in cruise you're going to accelerate, not decelerate. What kind of heading, westerly or easterly? Pay attention to that. Westerly heading. Direct reading compass will indicate northerly turn, southerly turn, no turn. So here it's not specified whether the aircraft is in northern hemisphere or southern hemisphere. So according to my knowledge, I have, yeah. So it's not mentioned here. So there is no error in printing or copy pasting this question, but let's consider this is in the northern hemisphere. So in the northern hemisphere, it will be a northerly turn. In the southern hemisphere, if this happens, it will be a southerly turn. Okay. Next, question 14. When turning right through 90 degrees to north, on Lambert's chart, great circles that are not meridians are what? So on a Lambert's chart, let's say this is your reduced Earth. This is the Earth, and the Lambert's chart looks something. So first you have a parallel of origin like this. Okay. And then when you shift this cone inside, when you shift this cone inside, okay, somewhat like this. It's not accurate. So you have standard parallels. Let's label this. So you have standard parallels, standard parallel number 1, standard parallel number 2, parallel of origin. So all great circles will be concave, will be concave to the parallel of origin. So like this, concave to the parallel of origin or convex towards the nearest pole. So it will be bending away. Its tendency will be to bend away from the parallel of origin like this, to bend away, okay, or bend towards the poles. So curves concave to the pole of projection, straight lines within standard parallels, curves concave to the parallel of origin. So option Charlie. Curves concave to the parallel of origin and convex or bending towards the nearest pole. Next, question 17. Parallels of latitude except the equator are what? So we know that on the earth, let's say the basics of great circle, rhumb line, latitudes, longitudes. Okay. On this earth, your equator is one particular latitude, unique latitude, which is both a great circle, and a rhumb line. Great circle and a rhumb line. But any latitude other than the equator is only a rhumb line because it runs in a constant direction east and west. Okay. So parallels of latitude except equator are rhumb lines because they have a constant direction east and west. Mass is given, heading is given, winds are given to you. Calculate drift angle and ground speed. So use your CX3, go to option wind correction, substitute the values or put the values here. 270, 270. Heading is 270. Winds 205 at 30. So ground speed will be 258.75 or 259er. Okay, ground speed. So ground speed is 259 knots. Drift angle will be the opposite of wind correction angle. Now wind correction angle here is minus 6 degrees. So drift angle will be plus 6 degrees. It will be plus 6 degrees. That means plus means right hand side. So the correct answer here will be option Charlie, 6 degree right and 259 knots. Drift and wind correction angles are exact the same, have the same values, are same in terms of values, but the signs will be different. If you are drifting starboard, you will correct that drift by pointing your aircraft towards port side, left hand side. If you are drifting left hand side, you will point your aircraft nose in to the right hand side from where the wind is blowing. So the values are the same, but the angles or the sides are different. Okay, indicating left for minus, right for plus. Question number 19. Task heading winds are given. What is track and ground speed? So task is 135. Heading 278. Winds 140 at 20. Ground speed 150 and true course 283. Correct. The nearest option here is option alpha. 284 track 150 knots. Question number 20. Last. Track heading variation task is given. Calculate true wind velocity. So we want a final answer in terms of true direction. So let's convert this magnetic track into corresponding true track or true course. So if magnetic is 210 degree and variation is 15 degree east, variation east magnetic will be least. Therefore true heading or true direction will be more than magnetic. So 210 plus 15, 225. So true track is 225 degrees. True heading is 215. Magnetic heading is 215. So true heading will be more than that. 215 plus 15, 230. You have true track, true heading. You have task. You have distance 64 miles. Time 12 divided by 60 hours. So ground speed of this aircraft will be 64 divided by 12 multiplied by 60. So 64 into 60 divided by 12, 320 knots. Ground speed is 320 knots. Substitute this. Ground speed 320, task 360, course 225, heading 230. So wind velocity is 264 at 49 knots. 264 at 49 knots, or the closest option is 50 knots. 264 at 50 knots. Simple. So this concludes our lecture. I hope you have understood all the 10 questions that I solved in this particular video lecture. If you have any doubts, any comments, suggestions, feedback, any queries, let me know in the comment box of this video lecture. I will definitely answer them. I request you all to share this video with your friends. Subscribe to this channel if you haven't yet, and hit the like button if you have liked this video lecture. Thank you for your time. Keep practicing, keep working hard.